Let's solve this Olympiad equation together. Okay, so we have 7 raised to power sine squared x plus 7 raised to power cos squared x is equal to 8. Okay, now the first thing we can do here is that we can multiply both sides by 7 raised to power sine squared x multiplied by the left hand side, and then you have to be equal to 7 raised to power sine squared x times 8 on the right hand side. Now, opening up this bracket, we have this to be equal to, remember that when you have a raised to power m multiplied by a raised to power n, it's equal to a raised to power m plus n. So here we are going to have this to be equal to 7 raised to power sine squared x plus sine squared x, that's 2 sine squared x plus, okay, now 7 raised to power this plus this becomes equal to 7 raised to power sine squared x plus cos squared x to be equal to 7 raised to power sine squared x times 8. Okay, now moving on, we have this to be equal to, now you remember that the law of indices states that a raised to power m or raised to power n is equal to a raised to power m times n. So this means that we can write this as 7 raised to power sine squared x all raised to power 2 plus, now sine squared theta plus cos squared theta is 1. So we have 7 raised to power 1, which is 7. It's equal to 7 raised to power sine squared x times 8. Okay, now let 7 raised to power sine squared x be equal to a, for example. So we have a squared plus 7 to be equal to what? 8a. Alright, so it means that what we have here is now a squared minus 8a is a plus 7 rather is equal to 0. Okay, now solving this, we have a and a, so we have a minus 7 into a minus 1 is equal to 0, and a is equal to 7 or 1. Let's say, recall that 7 raised to power sine squared x is equal to a. So we say when a is equal to 7, we have that 7 raised to power sine squared x is equal to 7 raised to power 1. The bases are the same, you can equate the powers, hence sine squared x is equal to 1. We have sine x to be equal to plus or minus 1. And invariably x can be anything from 0, 90, 180, 270, 360. Okay,